Oops, go back. Hi, I thought I'd go through these proofs one more time. Feel free to stop the video and take a break and go from page to page, skip pages, and go to whatever proof you need. So here we have given to us triangle ART and line segment ATS. Remember, when we're given a line segment, it's most likely because we're going to be using either vertical angles or linear pairs. You can see we don't have vertical angles here, but we do happen to have a linear pair. Given a triangle, looking at the triangle, we have the three angles of a triangle. We'll most likely be using the fact that the three angles of a triangle add up to 180. Let's look at the proof. This is a proof where some of the steps are given to us. So here we have step 1, which is always going to be the given. We'll fill that in. Step 2, we have the measure of angle W plus the measure of angle X plus the measure of angle Z. Let's look at our diagram. X, W, Z. Those are the angles of a triangle. They equal 180. That should be easy. The angles of a triangle add to 180. Or you could simply write sum of the angles in a triangle equals 180. Step 3. X and Y are supplementary. Let's take a look at where X and Y are. These two angles right here. Well, they happen to be our linear pair. We know they're supplementary because linear pairs are supplementary. Remember, we don't have to define linear pairs. And I'm going to abbreviate here. In the next step, which follows from 3, we have measure of angle Z plus measure of angle Y equals 180. Well, look what came before. Z and Y are supplementary. We know that when we add Z and Y, we get 180 because supplementary angles add to 180. So, supplementary angles add to 180, or have a sum of 180, however you want to state it. Step 5, what could we do next? Well, we've used on our givens, and looks like we've used our diagrams. Although there might be more I could do with the diagram, I want you to notice something. We have 180 here and 180 here. Those two happen to be a match. So from here we can use the substitution property. I know when I have a match there, I can use substitution. Oops. Substitution property. And if both these are 180, 180 is this, and 180 is this, then both of these pieces must in fact be equal. So in the next line, I'm going to take measure of angle W plus the measure of angle X plus the measure of angle Z. I'm going to have to squish this in here a little bit. Equals the measure of angle Z plus the measure. What I'm going to do, I'm going to move this over. Let's see if I can erase that. It's not letting me erase the substitution. Okay, well, measure of angle Y. Alright, it's a little bit squished, but I think we can see it. So let's look at what we have and what we're trying to prove. We're trying to prove that X plus W equals Y. And we have X plus W equals Y. We have there, and we'd like to get rid of these two. If we could get rid of these two, then we'd have what we need. So if we just write in the next step the measure of angle Z equals the measure of angle Z, then we could subtract that out and be left with what we need. Step 6 is the reflexive property. We have an equals minus an equals, and we get equals. And there you have it. You can replay this video, you can do it again on your own, and I would suggest taking a break before we do the next one. I hope this helped. Hi again, back for more. Here we have the next proof in our packet. We have intersecting lines R and S, and we want to prove that vertical angles are congruent. That means we can't use the fact that vertical angles are congruent. What we've been given is intersecting lines. Remember I told you that when we are given intersecting lines, it means we're either going to use vertical angles, which we can't use because we're proving that, or we're going to use the fact that we have linear pairs. And we have 1, 2, 3, 4 of them. That's what we're going to be using in this proof. Let's start with our given. Write down your given and the reason, and I'll come back. Now that we wrote our given, we pick one pair of angles representing a linear pair. I'm going to start with x and y. I could have picked wx, I could have picked wz, or I could have picked zy. I just happen to pick x and y. So what we know about them is that they're supplementary. We don't have to define a linear pair. X, y are supplementary, and that's because linear pairs are supplementary. I'm going to abbreviate. Hope you're okay with that. In the same step, because it's the same reason, we want to pick two more angles representing a linear pair using one of these two letters. Again, looking at our picture here, looking at our diagram, we already used x and y. Maybe I'll take y and z. So y and z are supplementary. I'm using it in the same step because the reason is the same. It saves me a little bit of work. We now have supplementary angles, and what do we know about supplementary angles? They happen to add up to 180. So in my next step, measure of angle x plus the measure of angle y equals 180. Whenever we talk about degrees, we have to use measurement. And in the same step, because it's the same reason, I'll talk about the measure of angle y plus the measure of angle z equaling 180. That's because supplementary angles add to 180. Pardon my messy handwriting. So where does that leave us? If you notice, I have 180 degrees here and 180 degrees here. We've said in class that when we have the right side being a match, then the left side has to be a match by substitution. So we know the next step is going to be substitution. It's okay to write the reason first. Substitution property. As soon as we figure it out, we can write it. And then we're going to take this left side equal to this left side. Measure of angle x plus measure of angle y is equal to the measure of angle y plus the measure of angle z. Pardon me going a little crooked. How does that help us? Well, let's take a look. We're trying to prove that vertical angles are congruent. We have x plus y equals y plus z. I notice I have y in both. Let's consider subtracting both of those out, because that's usually what we do when we have a match on both sides. If I got rid of the y's by subtraction, I'll be left with x is equal to z. Going back to our diagram, that's our vertical angles. So let's subtract out the y's. First, I have to state that the measure of angle y equals the measure of angle y by reflexive property. Remember, before you subtract something out, we want to subtract these out, we have to state that it's equal to itself by reflexive. Now consider them being subtracted out, leaving us with the measure of angle x is equal to the measure of angle z by subtraction property. And we've done it. We've just proven that x and z, which happen to be vertical angles, are congruent. There you go. We'll go on to the next proof, but if you need a break, take one and then come back to the next page. Hello again. On to proof 3. This one looks a little better because it's only 4 steps. What we're proving here is that the measure of angle W plus the measure of angle Z, X plus Z. So W plus X plus Z equals 180. Let's see what that looks like in the diagram. That's W plus X plus Z equals 180. Well, we've been given a triangle, and I know that the angles of a triangle add up to 180. I also know these are vertical, and they're equal. So perhaps we're going to do some vertical angles and some substituting into the angles of a triangle. Looks like that's where we're going to go. Set up your given, and then I'll come back. I'm back. I've also added step 2. I figured that once you knew you had the triangle, you'd realize that you could take its angles and add them up, set them to 180, with the reason that the angles of a triangle add to 180. That should be a fairly easy step. From here, we've used our only given, and we need to go to the diagram to see what else we can do. From the diagram, we can use the vertical angles here, so let's do that in the next step. Measure, and let's keep it in measurement, since step 2 is in measurement. Measure of angle W equals measure of angle Y. Oh, this is going to be a very short proof. And what's the reason there? Vertical angles are congruent. We can't just say vertical angles because that doesn't really tell us anything. It's just a statement, vertical angles. We need to say vertical angles are congruent. That tells us more. So now we know that W equals Y. So right here, Y is the same as W. Why don't we do a little substituting, and we will have the measure of angle W plus the measure of angle, you know what, let's do it in order actually. I'm going to take this statement here, I'm going to write it just like it is and replace what we have. So the measure of angle X plus, now instead of Y, I'm going to replace it with W. Measure of angle W plus measure of angle Z equals 180 degrees. That's by substitution. Property. If you really want, we could rewrite it in step 4 as measure of angle W plus the measure of angle X plus the measure of angle Z equals 180, just to make sure it's in the same order that it appears here. But you're done. That's it. Some proofs are shorter than others. If you're ready, we can move on to proof number 5. Or take yourself a break and come back. Now on to the 5th proof. Looking at the given, we know that we have a diagram. Right, that's it. Doesn't seem like a lot, so let's look at the diagram. I see a pair of vertical angles. I wasn't given all 3 angles in the triangle, but if you look, we have an exterior angle. You need to recall the exterior angle theorem, which says an exterior angle of a triangle is equal to the sum of the 2 remote or far interior angles. So let's use that and see what happens. If you look ahead and make a plan, you could say W equals X plus Z. W equals X plus Z, but we need Y. Well, X equals Y. So we'll do some substitution. Step 2, I'm going to say that the measure of angle W equals the measure of angle X plus the measure of angle Z. And that's your exterior angle theorem. This will be a nice short proof since we've done so many so far. 3, let's use our vertical angles. That the measure of angle X equals the measure of angle Y. Remember, don't just say vertical angles, because that's not telling us very much. You need to tell me vertical angles are congruent. So now, since x is the same as y, here's the x, we just do a little substitution there. Step 4, last step. We will have measure of angle W equals measure of angle Y plus the measure angle Z, because we took this X and replaced it with Y. Reason, substitution, good old substitution property saves the day again. You're going to notice, or you should have noticed by now, that some properties we use over and over. We've been using the substitution property over and over. We use the vertical angles or congruent property a lot. We use the sum of the interior angles of a triangle property a lot. That's why we need to get to know our properties. That's it for this page. Again, why don't you take a break and come back for the next page. Hope this has helped so far. We just had 2 fairly easy proofs. This one looks complicated, but it's really not. It just looks different than what we've done in the others. We have a diagram. That's the given. In the diagram, notice we basically have 2 triangles, one inside the other. And there's a hint here. You will need to write a label in the diagram that's not labeled yet. Sometimes we can do that. We can always do that, but sometimes we need to do that. So I added C here. If it helps you, you can separate the triangles. If it helps, we have a big one, and then we have a smaller one. You have X, W, C, then you have Z, Y, C. Sometimes it's really helpful to pull the triangles apart when one is inside the other. Since I have triangles, I'm going to start by talking about their measures of their angles. Measure of angle X plus measure of angle W plus measure of angle C equals 180. That's the large triangle. I'm going to give you a minute to write the sum of the measures of the smaller triangle and write the reason, and then I'll come back. Okay, hopefully you've got down that the measure of angle Z plus the measure of angle Y plus the measure of angle C equals 180. Z plus Y plus C equals 180 because the angles of a triangle add to 180. Look carefully what you have in step 2. Notice that you have 180 here and 180 here. You've got a match on the right side. Now, I want you to try to be able to finish this on your own, so we're going to do one step at a time. I'm going to leave you for a minute. I want you to do the next step, knowing that you've got 180 on the right side, and we have a match on the right side. See if you can do the next step, and I'll come back again. What you should have is measure of angle X plus measure of angle W plus measure of angle C from here set equal to measure of angle Z plus measure of angle Y plus measure of angle C from here, using the substitution property. Remember, if these are both 180, then these must equal each other. Now look closely at step 3. Do you see anything in both of these that might be the same? Yes, I have a measure angle C in both. Remember what we do when we have the same thing on both sides? Hopefully you do. I'm going to leave you with step 4. See if you can figure out what has to happen next. Keep your eye on what we need. We need Y plus Z equals W plus X. We need W plus X and Y plus Z. If only we didn't have these. I'll leave you to it, and I'll come back. So let's finish this up. You should have had the reflexive property stating that C is equal to C, so you could basically cross those out in the next step. Using subtraction, if you subtract those out, you'll be left with the measure of angle X plus the measure of angle W will be left equal to the measure of angle Z plus the measure of angle Y. By running out of room here, the subtraction, really running out of room. Oh, I can fit it. Property. So let's see if that's what we needed. X plus W equals Z plus Y. Z plus Y. There you have it. And we're done. Not too many steps. So congratulate yourself. You got through 6 proofs. I think there might be more. Let's turn the page. Hi again. I've marked this diagram up already. We are given that AC is equal to BD. AC is this entire segment, which is equal length to this entire segment. And I've noted in green what we need to prove. We need to prove that this little piece is equal length to this little piece. So if we have a large segment, we need to make it smaller, and a large segment, we need to make it smaller. We're going to need to do some subtracting. And you'll notice that they both share this piece. That's what they would essentially overlap. That piece is going to have to be subtracted from both. They share that. And typically when there's something that 2 triangles or 2 segments share, or 2 angles share, we use reflexive. So I know we're going to be using some reflexive, and I know we're going to be using subtraction. I also know that this blue segment is made of 2 pieces, and the pink segment is made of 2 pieces. Let's start by talking about what AC is made of. AC is made of AB plus BC. And in the same step, let's talk about what BD is made of. BD is made of BC plus CD. There we go. What did we just use? Well, we just spoke about a whole being equal to the sum of its parts, and that's the partition postulate. Step 3. Well, I notice once I've done that, I already knew AC was equal to BD. So if these 2 are equal, then this must be equal to this. So let's write that down by substitution. AB plus BC must be equal to BC plus CD. Hopefully you can tell that's a B. And we just did a little substituting. Substitution property. I'm going to abbreviate. Well, how does that help us? We want to know AB equals CD. We want to know AB equals CD. But we have BC in the way. That's what we're going to subtract out in step 4. But in order to subtract it out, we need to first state that BC is equal to BC using the reflexive. Consider that way I could really subtract it from both sides. Here we have the reflexive property. We're almost done. And lastly, after we subtract it out, bring down what's left over, we have AB is equal to CD. And that is our proof. We did it by last step subtraction property. How easy was that? Nice and easy. We can move on to the next one, or you could take a break. Back for more, this time with angles. I've labeled the diagram again. We have measure angle MAH. MAH, that's the green, is equal to the measure angle TAG. And we want to prove that the measure angle MAT is equal to the measure angle HAG. Looks like, again, we're starting with a big angle, and we want to end up with a smaller piece. Starting with a big angle, and we want to end up with a smaller piece. They both have this angle here, TAH, that they share. That's the overlap. They both overlap there and they both share it. And we're going to have to get rid of that. If we get rid of this middle piece, then we have the two smaller angles. Looks like subtraction again. So let's go and talk about what the angles are made of. Measure of angle, MAH. What's that made of? Equals the measure of angle MAT plus the measure of angle TAH. I know it's a little hard to see, and I'm writing very large too. The next angle, measure of angle TAG, the blue one, is equal to the measure of TAH, oops, different letters, angle TH plus, goodness, it's hard to write on these words, H plus the measure of angle HAG. And I'm sure you know what we used this time. Again, we spoke about a whole angle equaling the sum of its parts. A whole is equal to the sum of its parts. Partition postulate. And again, I'm going to abbreviate. Step 3. Let's take a look. We already know MAH is equal to TAG. MAH equals TAG. The left sides match, so the right sides will match. I'm going to let you do step 3, and I'll come back. How did you do? Hopefully, you took the right sides and set them equal to each other. I ran out of room, so I did it this way. MAT plus TAH is equal to TAH plus HAG, and that was by substitution. Now we have, take a look, TAH here, let's use this, TAH, which matches TAH. Those two are a match. If I were to subtract those out, I'll be left with MAT equal to HAG, and that's exactly what I want. Step 4, in order to subtract them out, remember, I need to use reflexive. I need to have something to subtract. Reflexive property. Remember, reflexive is equal to itself, not something else. So now we can subtract on the left side this one, on the right side that one. In step 5, I'm left with the measure of angle MAT will equal the measure of angle HAG. And do you recall what we just did? We used the subtraction property. Look at all these properties that we keep using over and over. There you go, 5 steps. And yes, we have some more. So take a break and then come back. Hello again. This is a nice short proof. In this proof, we were given the diagram with intersecting lines and angles X, Z, and Y already labeled. It says the following proofs, or proof you're given may just be the diagram. You also may need to label an existing angle. I labeled this one R because I figured I might need to use vertical angles. So I looked ahead and made a plan. If I was to prove that these 3 added to be 180, I knew that I could take these 3 angles and add them to be 180. And if I could get Y to be over here, then I'd have 180. So Y and R are congruent, and I'll use substitution. I started us off that are given, and then I use the fact that Z plus R plus X, Z plus R plus X equals 180. My reason? Give a minute to think. Think of what they form. Straight line. So consecutive angles that form a straight line. It doesn't look like the word straight, does it? Fix that. It's a little better. Add to 180. We don't say they're supplementary because supplementary angles are 2 angles and we have 3 angles here. Next step would be to talk about the fact that R and Y are congruent because they're vertical. So, or equal. Measure of angle R equals the measure angle Y. And step 3, we're not just going to say vertical angles, remember? Because that doesn't really tell us much. We're going to say vertical angles are congruent. So now, if R is the same as Y, and we really need a Y here, we're just going to do some substitution. Measure of angle, I'm going to keep it in, actually the order doesn't matter, so measure of angle Z plus the measure of angle Y plus the measure of angle X equals 180 degrees, and I used substitution. I think we've used that in every proof today. Substitution property. Bingo. We are on a roll. Next proof. Hello again. This proof is very similar to the one we just did, or some of the previous ones, plural, we just did. We're supposed to prove that m plus a plus h is 180. M plus a plus h is 180. We know that m plus a plus t is 180, and we know that t is congruent to h. So, put those together, use a little substitution, and you've got your proof. It should only be, I believe, 4 steps. I'm going to let you try it. I would start with this fact, then I would go to this fact, and then I would do my last step, which we've used over and over in a couple of proofs. Pause the video, do the proof on paper, and then come back and check your answer. I bet you'll do great. Just checking in, letting you check your next step. Measure of angle M plus measure of angle A plus measure of angle T is 180 because the sum of the angles in a triangle equals 180 degrees. Okay, let's see what you do next. Okay, next step. Measure of angle T equals measure of angle H because vertical angles are equal. You can say congruent, but in this case I said equal because we're in equality. Last step we'll do together because T is the same as H, and we really want an H here. We're going to do some substitution and say measure of angle M plus the measure of angle A plus the measure of angle H equals 180 degrees. Property, substitution once again. By now you could probably do these proofs with your eyes closed. Hope that helped. And take a break or go on to the next page. Okay, in this proof it's almost exactly like one of the previous ones we did, except in the previous one we had to add our own letter here, and I believe I added a letter C. We have 2 triangles, a large one and a small one, one inside the other. If it helps you, you can separate them, but I think we could do it in this case, keeping them intact. We have a label diagram as our given. What happened to those letters? Let's see. D-I-A-G-R-A-M. Something happened to the word there. In any case, we know that the measures of the angles of a triangle add to 180. I did step 2 for you. Measures of E plus G plus T equals 180. That's the large triangle. Measures of O and M and T equal 180. That's the small triangle. Reason that the angles of a triangle add to 180. So the next step, you should notice you've got 180 for both on the right. When the right side's a match, the left side's a match. And by now, what step is that? That's right, substitution. And that's going to look like this. Measure of angle E plus measure of angle G plus measure of angle T equals measure of angle O plus measure of angle, oops, let's make that small m. Measure, I'm just going to continue to the right, m plus measure of angle T. And that was substitution. Not a lot of room here. Substitution property. A little harder to see because of the way it's written, but we have E, G, T, O, M, T. I heard myself say T in both of them. T, T. Remember, when we have the same thing on both sides, we want to subtract that out. But first we have to state that the measure of angle T equals the measure of angle T. That way I can subtract it from the left side and subtract it from the right side using subtraction property. Hopefully you're able to do this a little neater on your paper with more room. Step 5, we're there. We now have measure of angle E plus G, there, is equal to O plus M. And I'm just going to write it in the order that they asked for it. Measure of angle G plus the measure of angle E equals measure of angle M plus measure of angle O. And we're done. On the next proof, we have a segment that's broken up into pieces, and we are given, let's see, let's use a highlighter. We're given GO, this entire piece, congruent or equal to EM. I think we did one just like this before. And we want to prove that GE is equal to EM. So actually we have an equality going on here. We have GO equal to EM. Those are the larger segments. And we want to prove that GE is equal to OM, the smaller segments. We have this middle segment that they share that we need to subtract out to make the smaller segments. We're going to be using subtraction. We can handle that. We've done this before. Let's write our given. Length of GO equals the length of EM. Given 2. Well, let's talk about what GO is made of. What two segments is that made up of? It's made up of segment GE plus segment EO. Got a little scrappy looking here. GE plus EO. I took that from here. GO is made of GE plus EO. Now we're going to talk about EM being EO plus OM. We can do that in the same step because it's the same reason. EM is equal to EO plus OM. And what is that? When you talk about a whole equaling the sum of its parts, partition postulate. Trying to be as neat as I can here. There we go. And look at that. We happen to know that GO equals GM. The left sides match. Therefore, the right sides should match. So I can say that GE plus EO will equal EO plus OM by the one that's come up a lot, substitution. Property. Let's look at what we've got now. We happen to have EO in both. And we want to prove GE to OM. I want to prove GE to OM. If I could just get rid of these guys, then I'll have what I need, GE to OM. I can do that by subtraction. I could subtract out the fact that EO is equal to EO. And what property is that? When something equals itself, reflexive. You guys are probably done and waiting for me. You're so good at this now. So now we've actually subtracted that out. And you should be left with the prove by subtraction property. I have made geniuses out of you. That got messy. Let me fix that. Okay. I think you guys should be feeling way better on these proofs. I really hope that helped. I think that's it. Let's take a... Okay, so that's it. The end of this recording, the whole thing. I hope this helped, and let's call it a day. Good luck. See you in class.